Vin Dang, and the topic of my presentation for today is the manufacturing of optical fiber for pulse laser application. First of all, who is Coractive? Coractive is an optical fiber manufacturer that was founded in 1998, where its location is in Quebec City, Canada. We deliver yearly more than 1,000 kilometers of optical fiber, and we are the only supplier of ytterbium true phosphosilicate fiber in the world. Another highlight of Coractive is that we are vertically integrated, meaning we have complete control of our manufacturing process, from glass preform production all the way to assembly of components and fiber lasers. Everything is done on site in Canada. So in terms of a solution, we provide two complete line of solutions for a customer. First of all, optical fibers. We offer an extensive selection of active and passive fibers for various application for different markets. And we also provide fiber lasers to our customer, which is high power CW lasers, MOPA pulse fiber lasers, and blue lasers. The markets that we are targeting are industrial, so mostly material processing, so laser cutting, laser welding, laser marking. And but we also target telecom application. We have a range of erbium dope fibers, attenuation fibers, and also photosensitive fibers. And lastly, we are targeting sensing application, which is mostly LiDAR, where we offer erbium ytterbium co-dope optical fibers. Of course, we are also targeting other emerging application with our various line of products. So coming back to pulse fiber lasers. The first thing we need to know is that what does the market need? So for new emerging applications such as deep engraving, trimming, micro welding, and cutting, the requirements are higher powers and higher pulse energy. As we're targeting industrial application, ytterbium fiber lasers are still the first choice, as it has operating wavelength in 1064 and 1080 nanometers. And of course, a MOPA configuration is also preferred as it offers high versatility. Here, what you see is the actual typical architecture of a MOPA configuration. And where Coractive plays a critical role is that it provides ytterbium dope double clad fiber. Of course, we do have a range of passive fibers that can be used in the design of the components for this type of configuration. And as I was mentioning earlier, the reason why MOPA lasers are preferred is for their flexibility and their versatility, meaning it's easier to modify the pulse repetition rate, the pulse duration, and the pulse shape, as well as the pulse energy. So when designing high peak power, high energy fiber lasers, what are the challenges? Of course, we have the limitation of nonlinear effects. So with high power, there are nonlinear effects such as SRS and SBS that are that can manifest. And also, we have to consider SBS whenever we are talking about narrow line width. So what do we need? In order to mitigate nonlinear effect, you need a fiber that has a high absorption, you need a fiber that has a large chord area, and you need a fiber that can offer high saturation energy. Another requirement for high peak power, high energy pulse fiber lasers is that the high beam quality has to be is a requirement. So our answer to actually address the challenges are the true or pure phosphosilicate fiber that can be used for pulse fiber lasers. Three main advantages. The first one is that it can offer high saturation energy. What does it mean? If you look at the graph on your right, a true phosphosilicate will have a lower cross emission. Basically, what it does is that it means that there's a higher population inversion, hence it can actually gather more energy in the glass matrix compared to a traditional aluminosilicate glass fiber. Secondly, it offers a true phosphosilicate offers higher absorption than standard aluminum phosphosilicate. What it means is that it will allow shorter fiber length, hence reducing the nonlinear effect threshold. Lastly, with these type of fibers, we use a pedestal design to lower the effective numerical aperture, and this procures a high beam quality. Of course, one of the main advantage of these type of fibers is that there is a batch-to-batch consistency, which ensure repeatable performances for large volume production. So right now, our product portfolio for pulse fiber lasers is the following. First of all, we offer a couple of fibers for MOPA configurations, such as the YB7 micron, the 8 micron, and 12 micron. We do also offer aluminum phosphosilicate fibers, such as the 10 micron and the 20 micron, which is suitable for Q-switch fiber lasers. Under development for us, upcoming in the future, we have the ytterbium 30 micron, the DCF YB3250EH, which is also for the Q-switch pulse fiber laser, which will allow to increase in power. We have the ytterbium 5400 PFAC, which is basically a true phosphosilicate fiber that will target laser cleaning, and we also will revisit the 20 micron and the 30 micron of pure phosphosilicate fiber. Thank you very much for your attention. If you have any question, feel free to contact me, and we will get back to you as soon as possible. Thank you.